no? For today, our topic will be the ideal gas properties and laws. So we're done with the first law of thermodynamics. And then, anong week tayo ngayon? Pang ilang week na ba to?
Week 5 po.
Week
5 po.
5. Okay. So, week 5 and up to week 7 will be dealing things about ideal gas, no? So, after natin dito sa properties and laws, we'll proceed with the ideal gas processes. Okay, open ko lang yung presentation ko. Start na tayo. Okay. Is my screen visible, class?
Yes po.
Yes po, ma'am.
Okay. So, good morning, class. Now, so today we'll discuss about ideal gas properties and laws. So, topics to be covered, we have the equation of state, the gas constant, ideal gas law, Charles law, Boyle's law, Gay-Lussac's law, and then last topic to be covered will be specific heat values and derivation. So, our topic outcomes for this ideal gas properties and law is for you to be able to identify the equation of state to determine the properties and working parameters of an ideal gas. Second is for the students to apply the thermodynamics properties of working substance and equation of state to evaluate specific heat value and ideal gas law. So for today, our goal is to cover up until ideal gas law. So except for specific heat lang. Para ito yung this will be our topic for next meeting. So next meeting we are again online class. And then the following week will be your quiz 1, no? Okay, start tayo. Magtatawag pala ako para medyo interactive. Mr. Miguel, can you read what is an ideal gas?
An ideal gas is a theoretical gas composed of a set of randomly moving point particles that interact only through elastic collisions.
Okay. So class ideal gas is a theoretical gas, no? So in reality, there is no ideal gas. So this is being so we have several assumptions just to prove or just to say or just to proceed with the calculations involving ideal gas. So we have 4 governing assumptions. What's the first one, Miss Luzelle?
Negligible volume. Ideal gases are assumed to have no volume themselves. They are considered point particles. In reality, gas molecules have volume, but this assumption simplifies calculations.
Correct, no? So for an ideal gas is assumed to have an negligible volume. But again, in reality, everything has volume, no? So just for the purpose of simplification ng calculations, we assume that ideal gas particles have no volume. So they're just point particles, no? They are considered to be point particles only. So next assumption, Mr. Charles.
Hello po, ma'am.
Hello.
Ma'am, ano po uli yung sa ano po? Medyo naglag po kasi sa...
Yung second assumption for number 2.
Okay po, ma'am. Thank you po. No intermolecular forces. Ideal gases are assumed to have no attractive or repulsive forces between molecules. This simplification helps in neglecting complexities arising from molecular interaction.
So, next assumption natin is that there is no intermolecular forces na nag-act between the particles or molecules of an ideal gas. So, why is that? It's because if we consider the forces acting on the molecules, it will make the equation or the calculation more complicated or more complex. So, in here, since, ayan, sige, later na lang. Third one, Miss Trisha, what's the third assumption?
Constant random motion. Ideal gas particles are assumed to move in constant random motion. This means they collide with each other and the container walls, leading to pressure exertion.
Okay, so the third assumption or the third governing assumption for an ideal gas is that the particles or the ideal gas particles are moving in a constant random motion. So, meaning the particles or the molecules of an ideal gas collide with each other as well as to the walls of the system or if it has a container. Next and the last assumption, may I call on Mr. Adonai?
Perfectly elastic collisions. Collisions between ideal gas particles and with a container wall. Container walls are considered perfectly elastic, meaning no kinetic energy is lost during collision. This assumption aids in simplifying calculations involving energy changes.
Okay, so fourth assumption is that ideal gas particles or the molecules of an ideal gas has a perfectly elastic collision. So meaning whenever the molecules collide, there's no loss of kinetic energy, or whenever they bump into the walls of the container, there is no loss in the kinetic energy. So we remember, no, in I don't know if we already discussed yung mga momentum na topics. So whenever an object bumps into something, so may momentum, no, sometimes there is a loss in energy, in the kinetic energy of the object. But in an ideal gas, we assume that merong perfect elastic collision. So kung mag-collide man, if there is a collision, no energy loss, no momentum, no, na nangyayari doon sa molecules ng ating ideal gas. So, as you remember, during our first or second meeting, we differentiate real gas from an ideal gas. So who still remembers the difference between a real gas and an ideal gas? Anyone from the class? What's the difference between a real gas and an ideal gas? Anyone still remembers the difference? Ala. The difference between a pure substance and an ideal substance. Anyone? Wala nakakaalala. So, a pure substance, no? As discussed before, the chemical composition remains the same even if there is a change of phase. However, in an ideal gas, there is no change in phase, no? So, there is no real example of an ideal gas, but we can consider or we can assume that air or oxygen, helium, and other gases can be ideal given that their composition is homogeneous. Okay, so are we clear on the four assumptions? So tatandaan tong apat na to, no? And also, we are clear on the definition of an ideal gas. Just to add, class, so systems with either very low pressure or high temperature enable real gases to be estimated as ideal. So remember that when we are studying or analyzing ideal gases, so the process is usually happening on at a very low pressure or a very high temperature. So these assumptions were given or were formulated or were characterized for us to have a predictable movement or the predictable outcome of an ideal gas or yung magkakaroon tayo ng predictable behavior ng gases when we have these four assumptions. Again, the four assumptions are, first, negligible volume, yung ideal gas particles natin. Next is there is no intermolecular forces. Third is that the particles move in a constant random motion. And the last assumption is that the collisions between the particles are perfectly elastic. Okay, so let's move to the next part, which are the laws governing the ideal gas, an ideal gas. First is the Boyle's law. Mr. EJ Sinchonko, can you read Boyle's law?
Boyle's law: if the temperature of a given quantity of gas is held constant, the volume of the gas varies inversely with the absolute pressure during a change of state.
Okay, so yung Boyle's law, class, was formulated by Robert Boyle, and it is uh, assumed, or it is formulated wherein the temperature of the quantity of gas is held constant, meaning all throughout the process there is no change in temperature. So the volume of the gas varies inversely. So we have here in color. So in this in Boyle's law, since temperature natin is constant, so we have ang natira na lang natin is di ba meron tayong PV equals MRT. So ito class is parang tip ko lang sa inyo for you to easily remember yung three laws natin for the ideal gas. So I always write this equation PV equals T. And if temperature is constant, if this is constant, ginagawa ko lang siya na PV equals C. And then if we have two gases and then P1V1 is equal to P2V2, considering that the temperature is constant. So relationship between volume and pressure. So inversely proportional, no, meaning if the volume of the gas increases, the pressure decreases. Again, when you say that the volume of the gas varies inversely with the pressure, meaning if your volume increases, your pressure decreases, or if your volume decreases, your pressure increases. So let's say meron tayong isang cylinder, let's say we have a cylinder. Let's say initially, this is a piston. Meron tayong piston dito. So if you have an increased volume, so let's say this is our setup B. This is the piston. Ito, mas malaki yung volume natin, right? As we push the piston downwards, let's say we have a downward movement of the piston, our volume decreases, no? The volume V1 is greater than V2 here. So this is your V1, this is your V2. So as you push down the piston, This the substance here will experience a higher pressure, or there will be a higher pressure on this setup comparing or versus this setup. So yun yung sinasabi ni Boyle's law. So we have here the graph. It just means that as the pressure, when you have pressure here, as you decrease the pressure, your volume increases, 'di ba? Let's say this is 5, this is 0, this is 5. If you have a 5 value of pressure, let's say ito yung 1, ang value mo ng volume is 1. However, let's say ito yung 4 and this is 2. So you can see if you lower the pressure to 4, you'll have a volume of 2, meaning as you decrease the pressure, there will be an increase in volume. Are we clear on this? On the Boyle's law?
Yes, naman.
Okay. So later, I don't know if everyone is already or paano ba? Parang gamay na gamay yun na yung three laws. But later, I'll tell you mnemonics which I just realized last night para mas madali yung matandaan yung Boyle's Law, Charles' Law, and the Gay-Lussac. So at the end of the three laws, tuturo ka sa inyo. Okay? So let's have a sample problem. So sample problem number 18 na tayo. Tama ba? What's our last problem yesterday? Class?
14 ata po ma'am ang last kahapon kung po ako nagkakamali.
14 lang ba? So,
15.
15 po
15
minutes.
po pa lang natapos.
15. So, di ba I sent you the compilation of the sample problems. Can someone run through the file and tell me which yung problem na hindi natin na-solve? Para I'll give ample time na ma-discuss yung solution. Do you still have the copy of the sample problems compilation? Kasi when I did this presentation last night, I based it on the sample problems compilation that I gave you. So the last problem that I have last night is sample problem number 17 already. So anyone of you can run through the sample problems and tell me which problems yung hindi na-discuss yung solution. Okay lang ba? Para ma-discuss ko sa inyo. Pero if you think or if you feel that you already know the answer, then wag na natin i-discuss. Okay? So anyone, kahit later, no, i-chat nyo na lang dito sa group. Okay. So for this problem, this is an application of the Boyle's Law. Again, sa Boyle's Law natin, Boyle's Law. Sinasabi niya na ang relationship ni pressure and volume is inversely proportional si pressure kay volume or vice versa. So we can also denote that as P1V1 is equal to P2V2, or pwede rin to class na P1 over P2 is equal to V2 over V1. Okay? So, given sample problem number 18, an ideal gas exerts a pressure of 3 atmosphere in a 2-liter container. What will be the pressure consequently? B. If the volume of the container is changed to 1 liter at constant temperature. So, nabanggit dito na constant temperature, so we are going to use the formula under Boyle's law. So we're given here of the initial pressure or the pressure 1, which is 3 atm, and then we have also the volume 1, which is 2 liters. Next is we are given of the final volume, which is 1 liter, and we are looking for the final pressure. So, using the formula for Boyle's law, it is just P1V1 equals P2V2. So, derive lang natin si P2. Divide both equations by V2. So, we have here P1V1 over V2. Nakakasunod lahat?
Yes po.
Okay. So, let's just substitute the given values. So, P1 natin is 3 ATM. V1 natin is 2 liters. V2 natin is 1 liter. So, our final pressure is 6 ATM, correct. So, box natin siya. Ito na. Okay, clear tayo? Proceed na tayo sa next law. Next natin class is Charles law. Mr. Billy Aguilar, can you please read? Billy?
Uh, the pressure on a particular quantity of gas is held constant, then, with any change in state, the volume will vary directly as absolute temperature.
Correct. So, in Charles law naman class, so this was formulated by Charles. Hindi ko sure if tama yung Jacques. But Charles is the one who formulated the Charles law. So, in Charles law, we assume here that the pressure is constant. So, di ba yung shinare ko kanina, lagi kong sinusulat is PV equals T. So, if I have the pressure to be constant, meaning volume over temperature ko is constant din. Parang tinranspose ko lang siya, nalis ko lang yung pressure since constant siya. Anyway, so going back, in Charles' law, we assume that the volume is constant and the volume vary directly as the temperature or the absolute temperature. So please always remember that when evaluating Charles' law as well as Gay-Lussac's law, temperature should be always in the absolute value, no? So it's either it's in Kelvin or it's in Rankine. Do not evaluate Charles' law, Gay-Lussac's law, and ideal gas law as well in Celsius or Fahrenheit. Always convert your temperature to Kelvin or Rankine. Sa tingin nyo, bakit? Why do we need to convert everything to Kelvin and Rankine before evaluating? Anyone? Kahit sharing lang or guess. Why do we need to convert in Kelvin and Rankine when evaluating gas laws? Try lang. Anyone? Sige, Mr. Hawson. Bakit kaya?
Ano po ma'am, kasi po yung mga ideal gas equations po ay proportional po sa absolute temperature.
Yes, that could be one. So, sinabi dito na absolute temperature. And another reason class is that when we have, for example, a 0 degree Celsius value and we evaluate using this formula and you have a 0 in the denominator, anong mangyayari? It will be undefined, right? So, and always remember, no, yung diniscuss ko sa inyo before, the absolute zero temperature is in Kelvin, which is 0 Kelvin. So meaning we can evaluate gases up to this temperature or before this temperature. So if naka 0 degree Celsius scale tayo, there could be possibilities that our answer will be negative, let's say negative or undefined. So again, pag pumunta na tayo sa Kelvin scale or the absolute temperature scale, our lowest temperature again is 0 Kelvin, wherein at this temperature, it is assumed that the particles or the molecules of a gas or any substance are perfectly crystallized. Do you still remember that? Again, at the absolute zero temperature, it could be 0 Kelvin or 0 degree Rankine. The particles of the molecules are assumed to be perfectly crystallized, meaning there is no movement na on the molecules of the substance. Kaya that's why we need to convert everything to the absolute temperature before we evaluate the gas laws. Okay? So going back to the Charles law, it is assumed here that the pressure is constant. So after the molecules or the substance undergo a process, there is no change in temperature. And it is stated in the Charles law that our volume varies directly proportional with temperature, meaning as the volume goes up, the temperature also goes up. If I have a 3 cubic meter substance, volume ng substance, and this was, we have an added heat, we expect the temperature also goes up. So, again, volume varies directly with the temperature. So, if we have that, we assume that the ratio between the volume and temperature, the ratio, again, ratio is ratio ng volume and temperature is constant. So, the initial and final equation, if we have a process or change in the substance, so we have the equation V1 over T1 equals to V2 over T2. So this is Charles' law. So let's have a sample problem. Sample problem number 19. What change in volume results in 5 liter of oxygen if 5 liter of oxygen is cooled by 5 degrees Celsius from 100 degrees Celsius? So I'll give you 1 minute. This is just direct substitution. 1 minute, please solve this sample problem. Okay, anyone who has an answer on this sample problem? Class? May nag-try ba mag-solve? So this is just direct substitution. Mr. Dave Simon Aguilar, answer? Aguila pala, sorry. Dave Simon? Go lang. Any 100 liters? That's wrong. Anyone from the class pa? Zeus, Dan? Zeus?
Ano po yan?
What's the answer here? Class, naintindihan ba yung tinuturo ko?
Opo.
This is just direct substitution, class. Yes, Mr. Reggie. Mr. Cardenas, what's your answer? What's the final volume? Sagot ni Mr. Cardenas is 6.708. Other answers from the class? Yes, Dave Simon. 4.924. So, malapit na. Okay. Discuss ko na yung solution. So, sample problem number 19. So, this is an application of the Charles Law. Again, kay Charles Law, we have the pressure to be constant. So, we are left with the volume and temperature. Volume varies directly or directly proportional sa temperature. So, ang equation natin dito is V1 over T1 is equal to V2 over T2. Initial volume natin, ang given data natin here is we have the initial volume of 5.00 liters. T1 natin, what's our initial temperature at this problem?
5 po.
So, ito class is cooled by 5 degrees Celsius, meaning there is a decrease in temperature by 5 degrees Celsius. This is the delta T. Again, no, class, yung words na ginagamit sa isang problem is very important no sa pag-analyze. So in this sample problem, it was said or it was stated that oxygen is cooled by 5 degrees Celsius. So there was a decrease in temperature of the oxygen by 5 degrees Celsius. So sinabi dito from 100 degrees Celsius. So this is your initial temperature. This is your T1. Naintindihan ba ng lahat? Class, gusto ko pumasa kayo sa subject na to ha. If hindi
Yes.
nagme-make sense yung sinasabi ko, there's no point. Binibigay ko na sa inyo lahat ng concept. Okay, so we have the initial temperature here. And we have the delta T kasi sinabi it is cooled by 5 degrees Celsius. So our T1 is 100 degrees Celsius. And it is cooled by 5 degrees Celsius. So meaning our T2 is, what's our final temperature if a substance is cooled by 5 degrees?
95 po.
95.
Correct, Robert. Thank you. 95 degrees Celsius. So we are looking for the final volume of the substance or oxygen. So applying the Charles law, But before we plug in the values, we have to convert these values, these temperature values to Kelvin. So T1, if converted to Kelvin, what's the value? What's the equivalent temperature in Kelvin?
373.15 po.
Correct. We have
73.
373.15 Kelvin. So that's the initial temperature. And then the final temperature is
368.15 po.
3,
68.15.
yes, 368.15. Oops, this is 15 Kelvin. So let's plug in the values in our formula. So ito, derive na natin yung formula to get the V2 or the final volume. So in order to get the final volume, we just need to cross multiply. So we have V1 T2 over T1. Nasusundan pa ng lahat. This is just simple derivation, no? So, plug in natin yung given data. So, V2 is equal to V1 natin is 5 liters. Our temperature to our final temperature is 368.15 Kelvin. And our initial temperature, T1, is 373.15 Kelvin. Our final volume is
33.
4.933 liters. Kasi makakancel na po yung Kelvin. So, this is your final volume. Nasundan po ng lahat?
Yes po, ma'am.
Okay. So now, let's proceed to the last law governing the ideal gas law. We have the Gay-Lussac's law. So if the volume of a particular quantity of gas is held constant, then with any change of state, the pressure will vary directly as the absolute temperature. So sa Gay-Lussac's law class, sulat ko lang ulit yung, sorry. Ang hineld constant for Gay-Lussac's law is the volume. So I am left with the pressure and temperature. So divide ko lang both terms to temperature. So I have here P over T, ito yung constant ko. So it is stated in Gay-Lussac's law that the pressure varies directly with the absolute temperature. So same with the Charles law. As you can see now, this is a relationship between volume and temperature if we're talking about Charles' law. However, in Gay-Lussac's law, we are talking about the pressure and temperature, the relationship between the two. So in here, pressure varies directly with temperature. So as you can see here, let's assume this is 1, 1, and this is 5, 5. 5 degrees Celsius or ito ay 5 atm. So at 1 atm, my temperature is 1 degree Celsius. However, if I increase the pressure, let's say ito yung 2 ko, 2 atm. Ang temperature ko nag-i-increase rin, no? So this could be 2.5. So again, Gay-Lussac's law, the pressure varies directly with temperature. And yung working equation natin is P1 over P2 equals T1 over T2. So, galing lang ito class dito. Let's say ito yung first state natin or first gas. And then after the process, we have this parameters. So, nag-cross multiply lang para makuha itong P1 over P2 equal to T1 over T2. Okay? So, let's have a sample problem under Gay-Lussac's law. Everyone, please solve. I'll give you 2 minutes. Raise your hand if you already have the answer. Yes, Mr. Hosen.
Ma'am, try po.
Mhm.
1.908 ATM po.
Correct. Very good. So, Gay-Lussac's law. Again, formula natin is P1 over P2 equals P2 equals T1 over T2. So, ang given natin for this problem ay initial pressure of 2.24 atm. Next is the initial temperature, which is 80 degrees Fahrenheit. So, we need to convert this to Rankine. What's the temperature in Rankine?
460 po.
Plus 80. 460 plus 80. 540. Next, given tayo of the outside temperature, which is also 0 degree Fahrenheit plus 460. So our final temperature is 460 degree Rankine. So we are looking for the final pressure of the tire given that we have a change in temperature. So plugging in the values sa formula na to. And for us to get the P2, let's derive muna the formula. So this is also equal to P1 over T1 plus P2 over T2. So P2 is equal to P1 T2 over T1. Initial pressure natin is 2.24 atm. Our final temperature is 460 Rankine. And then our initial temperature is 540 degree Rankine. And our final pressure after the change in temperature is
1.908 ATM po.
so this is 1.908 148 ATM, or P2 is 3 decimal places is 1.908 ATM. Nakuha ng lahat? Okay. Now, if everything is clear with the 3 laws, i-share ko lang yung para lang mabilis nyo matandaan yung tatlong law, no? Pero depende naman sa inyo kung you have already a way on how to remember those 3 laws. So, ako kasi, um, inano ko siya as tinandaan ko siya as, for example, I have Charles Law. Di ba meron akong relationship between volume and temperature. And then kay Boyle's law, I have the relationship between pressure and volume. And then kay Gay-Lussac's law, I have the temperature between pressure and the relationship between pressure and temperature. So, pwede niyong gawin is parang yung phrase na merong pa-VB sa Cavite na nag-chat GPT. Pero choice nyo if gusto nyo ring gawin para matandaan. So, merong pabebe na taga Cavite na nag-chat GPT. Choice nyo lang naman. Para lang naman matandaan nyo. So, again, Boyle's law, relationship between pressure and volume. Charles' law, relationship between volume and temperature. And then, Gay-Lussac's law, relationship between pressure and temperature. But, ito hindi lagi siyang directly proportional. Isusulat nyo yung PV equals T. So, if I'm talking about Charles' law, volume and temperature lang to. So, aalisin ko to. So, ang constant ko dito ay V over T. Ganon si Charles' law. Next naman, Boyle's law. Sa Boyle's law ko, sulat ko ulit PV equals T. This is a relationship between pressure and volume. So, aalisin ko yung temperature. So, meaning, if I divide both equations by volume, magkakaroon ako ng 1 over P over V. So, meron tayong inversely inverse relationship ng pressure and volume. And then, lastly, kay Gay-Lussac's law naman, so, sulat nyo ulit si PVT. And this is a relationship between pressure and temperature. Aalisin ko si V. And divide ko lang both by T. So, ito yung constant ko. Constant. So, meaning, yan, P1 T1 equals P2 over T2 na siya. Okay? Choice niya naman siya. If you want also to use those phrase pala. That phrase. Okay. So, we're done with the 3 laws. And bakit ba natin diniscuss yung 3 laws? Kasi pupunta na tayo sa equation of state or characteristic equation of a perfect gas. So, di ba kanina sa intro, I talked about the EOS or equation of state. EOS or equation of state. Wait lang. Okay, equation of state or characteristic equation of a perfect gas. So, an equation of state or EOS class is an expression that relates pressure, temperature, and specific volume of a gas. Again, the equation of state of a perfect gas is an expression that relates pressure, temperature, and specific volume of a gas. And the basic or the most basic equation of state is this one. Pen. Ito yung most basic equation of state. So we have pressure, we have the specific volume equals RT. So explain ko later why. So equation of state is the combination of the 3 laws. We have the Gay-Lussac's law, the Charles law, and the Boyle's law. So pinag-combine tong 3 law and then nabuo yung constant natin or relationship na P1V1 over T1 is equal to P2V2 equals T2. So the ratio or the relationship between the three uh, parameters is constant. And then we have the ideal gas law, which is PVMRT, where P is the pressure, capital V is the volume of the substance or the gas, equals the mass of the gas, the gas constant, or this universal gas constant whatsoever, and then the temperature. T is the temperature, and again, for every gas law, we need to convert the temperature to its absolute temperature scale. It's either Kelvin or Rankine. So, kaya siya naging specific volume class. So, remember, no? Formula natin for specific volume. This is specific volume. Formula here is, ano nga ba formula ng specific volume? Hello? What's the formula for specific volume?
1
Yes.
over density po.
Yes, tama, no? 1 over density. And what's the formula for density? We have mass over volume. This is volume, capital V. And since our specific volume is just the reciprocal of the density, then our specific volume is volume over mass. And as you can see here, sa ating ideal gas law or sa equation of state natin using pressure, volume, and temperature, if I divide both equations by the mass, let's say MRT, dinivide ko siya, both equations by mass, magkakaroon ako ng P, pressure, times V over M equals, wala ng M, RT. Ano ulit yung V over M ko? Ito, which is the specific volume. So, babalik dito, the basic equation of state of a perfect gas is pressure times the specific volume is equal to RT. Naintindihan ng lahat kung paano nangyari to? Okay. So, ano naman? Just a review. What's the gas constant for air? Anyone? Nakakatanda, ano pa ang gas constant ng air? Kasi yun yung madalas natin makakasalubong. Adham, do you know what's the gas constant for air? Norgeline? Yes, real, Alfred?
0.287 kilojoule
Correct,
per kilogram Kelvin.
Kelvin. So R of air, the gas constant of air is 0.287 kilojoule per kilogram Kelvin. So let's analyze bakit nangyari to. So in English unit class, we have, sige, first let's discuss the SI. Doon muna tayo sa madali. SI unit, we have the formula or the unit for pressure to be Newton per meter squared. Diba, this is force over area. So unit for force is Newton, area is m squared. And then we have the volume, which is cubic meters. We have the mass, which is kilograms. Temperature is in Kelvin. And then the value of the gas constant is Newton meter all over kilogram Kelvin. So, in English units naman, we have PSI, pwedeng PSI or pound force over feet squared if we convert the inches to feet. And then the unit for volume is cubic feet. The unit for mass is pound mass. And we have the unit for temperature, which is Rankine. So, absolute temperature tayo in English. So, value natin ng R is foot pound force over pound mass degree Rankine. So, di ba, PV equals MRT. So, if we are going to solve for the R, in English, R natin is equal to PV over MT. So, ito ay, ang pressure natin is pound per feet per feet squared times volume natin is cubic feet all over. So, this is, pressure is pound force ha. Lagi siyang pound force since force over area ang pressure. So, mass natin is pound mass times the temperature in Rankine. So, makakancel na yung feet squared dito. Mawawala na yung, magiging isa na lang yung feet dito instead of cubic feet. So, ayun yung unit natin for the R, for the gas constant. We have here pound force times feet all over pound mass. This is the unit for mass and degree Rankine for the temperature. Clear sa lahat? Kung bakit ganito yung naging unit ng gas constant? So, same with the SI unit, no? So, in SI unit, we have naman PV equals MT din. Ang pressure natin is naka-Newton per meter squared times volume natin is cubic meters. Mass natin is in kilograms. And our temperature is in Kelvin. So, makakancel yung meter squared. Matitira lang yung isang meter sa taas. So, we have Newton meter per kilogram Kelvin. Ma'am, bakit po kilojoule per kilogram Kelvin to? Yung sinabi kaninang value ng gas constant. It's because Newton times meter is joules. So, per kilogram Kelvin. Naintindihan? Any questions, class? Do you want any clarifications or do you need any clarification?
Clear naman po.
Clear naman. Okay, so now let's try to solve a problem. Wait lang. So, review ko lang, no? Sabihin ko lang ulit. This is ideal gas law. And the ideal gas law is the equation of state of a hypothetical ideal gas. Again, wala naman, in real life, hindi ito nag-exist. But for the sake of understanding the behavior of gases, we need to use yung four assumptions kanina na na-discuss at the start of the discussion para ma-predict na natin yung behavior ng gases. So, there's a study before class. So, nabasa ko lang to. So, the researchers, we have a researchers, They found out that no matter what gas you study, if you take one mole sample of that gas and put it in the same container and maintain a constant temperature, the pressure is almost the same, and at lower densities, even those tiny differences in the measurements also disappear. So, at really low densities, all the real gases tend to obey one universal law, which is the ideal gas law. So, nagkakaroon din tayo ng analysis of the ideal gas law if a substance has a very low density. Yun lang. Okay. Punta na tayo sa sample problem natin. So, I'll give you, this is also direct substitution. I'll give you 2 minutes to answer sample problem number 21. I'll randomly call someone to discuss his or her solution. Ano, para naman lahat ay nagsosolve. I don't know if nagsosolve ang lahat, but I want everyone to try answering these problems. Okay, sample problem number 21. Kindly solve and we'll discuss the solution after 2 minutes. Okay. Shane, Valerie, please discuss your solution.
Ma'am, ang ginamit ko pong formula ay P1B1 over T1
Mhm.
equals P2V2 over T2.
Correct.
Pagkuha
That's
naman po ng T2 equals P1B1 T2 over T1V2.
mhm.
Tapos sinubstitute ko lang po ang final answer po ay 812.196 mmHg po.
Okay, that's correct. Any questions from the rest of the class? Nakuha ba ng lahat yung same answer?
Oh,
Opo.
Raise your
Opo.
hand if you want me to discuss the solution. Again, raise your hand if you want me to discuss the solution. Else, we'll move to the next problem. Okay, so I see here few hands. let's discuss the solution. So in this problem, we are given the initial temperature of the gas, which is 303 Kelvin. And then volume or initial volume, we have 2 liters. And then initial pressure natin is 760 mmHg. Next naman, the sample shifts to a temperature of, so there was an increase in temperature. So we have 340 Kelvin. And then yung volume na daw was changed slightly. So nag-increase slightly to 2.1 liters from 2 liters. We are asked to find the final pressure. So using the ideal gas law, so in this problem we are not given of the mass and the gas constant, but we'll use the relationship between the three parameters. So mentioned, as Shane discussed her solution, she used the formula P1V1 over T1. So ito yung constant sa equation of state natin. So this is equal to P2V2 over T2. And then derive natin to solve for the final pressure. Cross multiply, tataas yung T2. So we have P1 V1 T2 over T1 times V2. So substituting the given values, we have P2 is equal to P1 natin is 760 mmHg. Initial volume natin is in liters. Temperature natin final is 340 Kelvin. And then our initial temperature is 303 Kelvin. And then we have our final volume of 2.1 liters. So makakancel na si liters, makakancel na si Kelvin, and our final pressure will be in mmHg. So 760 mmHg is also equivalent to how many atmospheric pressure?
1 po.
Correct. So, solve lang natin. 760 times 2 times 340 all over 303 times 2.1. We'll have the answer 1.0. Sorry, this is in ATM. Because I used ATM. But it's okay to use mmHg. I-convert ko na lang. So, sorry. I solved it in ATM. So, the answer in mmHg is, in your calculation, 800
812.195 po.
mmHg. So, if we are asked to express our answer in ATM, it is 1.068678296 ATM, or 1.069 ATM. So in your quiz naman and exams, I'll put a statement on which unit you will use for your final answer, no? Yan lang. So this is your answer for this one. Okay, naintindihan ba ng lahat? Any
Opo.
questions? Okay, wala. So now let's proceed to the next sample problem. So I'll give you 2 minutes again. So you collect a gas at 620 millimeter of mercury and 177 Kelvin. At the time of collection, it takes up a volume of 1.3 liters. What will the volume of the gas be when it moves to standard temperature and pressure? Okay, I'll let you solve this, but just to help you, what is our STP, standard temperature and pressure? Have you encountered this already during the previous semester, the STP class?
Yes po.
So what's the standard temperature?
273.15 Kelvin po.
Correct. And what's the standard pressure?
1 atmosphere po.
Correct. So solve for this problem. Okay, Mr. Robert Paul Panapio, please discuss your solution.
Ah, ang nakuha pong sagot is 1.637 liters po. Ang ginamit kong formula is yung PVT, yung P1V1 over T1 is equals to
Mhm.
P2V2 over T2 po.
Mhm. Correct.
Then, nag-substitute lang po ako.
Okay, good. Very good. That's correct. So, need pa ba i-discuss yung solution? Or nakuha na ng lahat? Raise your hand if you want me to discuss the solution. Wala? Okay na? Nakuha ng lahat? Wala nang tanong?
Nakuha po, ma'am.
Okay. Very good. If that's the case, let's move to. So the answer here is we have 1.637
7 po.
liters. Okay, next. 7 minutes left. I'll give this to you as assignment. Itong remaining two problems. So take a screenshot. Okay na? And then sample problem number 24. So for sample problem 23, please solve this on your own, no? I don't want na magre-rely lang kayo sa online. I want you to solve this on your own. And if hindi talaga, magpaturo muna sa kaklase, no? Ask for help from your classmates for you to be able to analyze these kinds of problems on your own. So sample problem number 23 and sample problem number 24 will be your assignment. So we'll discuss the solution on our next meeting. So next week will be online class pa rin, Saturday and Sunday. And then tatapusin na natin yung ideal gas law. I think up to yung specific heat and derivation. And then quiz tayo sa March 9. So 1.5 hours yung ating quiz. Again, may problem solving. And then you'll also have could be identification, true or false. Pwede rin enumeration if I want. Okay? So yun lang class. Hope you learned something during our discussion. If you have any questions, I'll give you the remaining time to ask questions. Yes, Mr. Zarilla.
Ma'am, kanina po ay wala pong internet kaya po di po ako nakapag-attend ng news. Kanina po pong unstable yung net ko.
Okay.
Pasensya na po.
Yung hindi mo naabutan, please catch up, no? Ask your
Okay po.
classmates what were discussed.
Okay po. Thank you po, ma'am.
Okay. I'll give you a copy of this presentation.
Okay po.
Okay. Other questions, class? Wala na po. Okay yun. So, siguro class, no? Whenever we are having online classes, please engage. Please participate. Medyo na ano ko kanina na wala man lang nagtatry, no? Mag-answer or mag-raise ng hand to solve yung problem given that it's already direct substitution. So, yun lang. I want everyone to participate, engage sa class discussion. Okay? Yun lang. Thank you everyone. Have a great day ahead. Stay safe.
Thank you.
Thank you po, ma'am.
Thank you po.
Thank you po,
Thank
ma'am.
you po, ma'am.